Hi, this is Shakil Ahmed. In this tutorial, we will study how to obtain the ordinal logistic regression results when we have survey weighted data. As in previous videos, I already discussed how and why we should use uh, these survey weights when we have a complex survey design. So I have taken again the example of National Health and Nutrition Examination Survey, which is a representative sample of US population. So I have just selected one cycle, that is the final cycle 2017 and 18. I have, and that consists of, you can see how many variables, and the dimension of data is, there are 9,000 observations you can see. So running, just wait. And then we have an ordinal variable that is smoking intensity, and we just want to see the association between age and sex with smoking intensity. Smoking intensity is measured on a three classes ordinal variable. Uh, Non-smoker, occasionally smoker, and a regular smoker. So just skip this one. So you can see there are 9,756 observations with 962 variables, and we are selecting the smoking variable. And just for simplicity, I am just ignoring the missing values, and we can just see there are three categories with different number of observations, and we required mass package for ordinal logistic regression with HMISG package. This is unweighted logistic regression. You can see the result of weighted logistic regression. That is 0.041 if we see the exponentiated beta, 1.04 for age and 1.07 for sex. This is unweighted result. Now we will see when we include the survey weight in our analysis, then how the result will change. So I'm just calling this survey package, and then the survey object, that is survey design. It includes primary sampling unit and survey weight, and then stratification variable. And I'm just checking how, how the weights are available in this uh, survey design object. So we have basically 92 infinite weights that are due to, I think, exclusion of uh, values from the whole data. Basically, I am just using the previous weight that is not a correct weight. Basically, this weight was obtained for 7 years. So you need to check whether whenever you are using the survey weights, you need to check the documentation how the weights were obtained. A guideline is available in on NES website, and if you are using any other survey data, then you need to check the relevant documentation for obtaining weights, and then you can include the weight in this design object, survey design object. So I'm just excluding the infinite values for simplicity. So I'm using the data set that consists of only finite weights. So I'm just applying survey design, all probability. This is weight basically. You can see in this object, survey design object. So that is less than infinity. It means only finite values are included. So you can just run this ordinal logistic regression for survey weighted data, SVYOLR, and we have a dependent variable that is smoking status, smoking intensity, you can say, and this should be a factor. If not factor, then you need to write factor. And we have predictors, sex and age, and we are basically checking the effect of sex and age on smoking. So we just got the beta values that are coefficients, and again we have the coefficients, and these are the intercepts. We are not interested in intercepts. These are category specific from category uh, one to two and two to three. So we are interested in beta. That is basically increasing 1 unit in age will cause an increase of 0.09 unit change in log of odds. Log of odds. And what is odd? Odd is basically the probability of smoking status is greater than 1 versus probability of y is less than equal to 1. Similarly, greater than 2 and less than or equal to 2. So we are just taking this out, and we are using if I can just show you the what is the log of odds. Log of uh, odds means log of probability of smoking is greater than 1 divided by probability of y is less than or equal to 1. So we are just checking the change in this log of these odds. And if you want to see the change in odds, then you need to exponentiate the coefficients, and we will do in next. First, you need the p-value. So we just obtain the p-value from the beta. Here we have values that data standard error, uh, estimate standard error, and the t-value. So on the basis of t-values, we obtain the p-values. We can just see the p-value, and I am adding the result in a form of a table, and you can see here we have the values standard error, t-value, and p-value, and you can just find the final table which include the estimates, t-value, p-value, and the odds ratios as well. I have also included the odds ratio. Odds ratios are basically the exponentiation of the result of values, this one. And these are 95% a lower confidence interval. This is lower one, and this is upper confidence level. So these are the values you can see now. Again, it is 1.04 to 1.07, just a little difference with the uh, unweighted logist result. You can just see where is unweighted result. You can just again check. So you can just compare these two results, 1.04 to 5. Almost these two results are same, but the standard error you can see, and the standard error are different, but here we are just obtaining the odds and their uh, these are not the standard error, these are the exponentiated standard error. So you can just check whether it is correct or not. So uh, this is almost giving us the same result as we obtained through unweighted data analysis. So it's not much affecting your result. But again, uh, we need to be very cautious while analyzing our data. We should include the survey weight when we have a complex survey design. Complex means we have different sampling mechanism on different stages, and we have stratification, and we have multi-vehicle stratification and clustering. So in that case, we need to check, and we need to incorporate appropriate weight. Thank you for watching, and don't forget to subscribe my channel.